Thank you for joining me for the general audience webinar for MEETS. So I'm going to talk about what different stakeholders need and what the barriers are at a high level, rather than getting deeply into issues for any particular stakeholder. The other webinars that we did earlier this week and last cover the utilities and the building owner issues in depth. So I'd encourage you to watch those if you haven't seen them and you're interested in more detail on those. Our philosophy about deep energy efficiency is that it's currently not scalable. And there are two fundamental reasons for that. One is that it undermines the utility business model. And the other is that the split incentives destroy the economics for the real estate community. So I'll walk you through those. From the utility economics perspective, this is a graph of the California power mix, showing that a significant chunk of that mix has been met by energy efficiency, which I think we'd all agree is good news. Here is the same sort of graph for the Pacific Northwest, showing load growth and the percentage of that load growth that's being met by energy efficiency. So that's terrific for society, et cetera. But if you are a utility executive, that's actually red ink. Most investor-owned utilities earn on generation, and for them, traditional energy efficiency is negative sales, lost revenue, and lost investment. We have many cities in the country that are growing rapidly and have flat or declining loads, and that's mostly due to things happening on the other side of the utility meter. That's a serious problem for utilities, and it's a serious problem for even municipal utilities who are concerned about unit loss in the system. The results of that are that utilities are going to resist energy efficiency at depth, at scale, so they will do what they're required to do from a regulatory perspective, but few utilities will do more than that. There are a few exceptions, but in general, if you want this to scale, we need a system that addresses this problem for utilities, or we will damage their balance sheets in the process of saving the planet. So utilities can't let this scale without changes to energy efficiency policy. And we see MEETS as a transaction structure that enables a different set of policy choices. On the building owner economics side, building owners are asked to invest and the tenants keep the savings. So in non-owner occupied buildings, that's a very serious problem. The result of it is what we always see, which is short-term paybacks if anything is done at all. I'm going to show you that graphically. Here is the available savings from a retrofit project. You can think about this in energy units, probably more useful to think about it in terms of dollars. If the vertical axis there is 100% of the savings from a retrofit project, and the horizontal axis is time, you would think that if you did a retrofit project and you maintained all of the measures over long periods of time and replaced them when they needed to be replaced, the result would be this block of savings from a financial perspective. That's what would be available to an investor who is interested in improving a building. What actually happens is this. This is the fall off in the maintenance and upkeep of energy efficiency measures. All utilities see these graphs. They all discount for them, as do the regulators. But the problem is worse than that, because if you're in a non-owner occupied building and you make the investment, the savings available to you is approximately this, because the tenants receive all the savings. So as an investor, you might get a bump at the very beginning from the incentive dollars. It's relatively modest, but you don't see the cash flows from the savings. That's the landlord-tenant split incentive. On the owner-occupied side, there's a different problem. So if you own a home, on average, you will own that home for 5 years. So the savings available to you from your energy efficiency investment is 5 years. If you look at the McKinsey studies and things like that, what you will see is that the average payback for a homeowner that they ask for with energy efficiency upgrades is 2.5 years. That's because on average, a homeowner will own their home for the next 2.5 years. So that's not a bad economic decision on their part. It's just recognition that they want to receive the savings while they currently own the house. That's their window. On the commercial building side, the average ownership of a commercial building is about 9 years. And if you look at the McKinsey studies, you once again see that the paybacks are 4.6 years if they're done at all. Again, that's a rational economic decision based on wanting to capture the savings during the time of ownership. So there are two split incentives in the real estate community. There's the split incentive between the investor or building owner on one side and the tenants on the other. And there's the other split incentive between the current owner of the structure and the future owner of the structure. Both of those split incentives drive short-term paybacks and drive inaction in many buildings. And that's, of course, what we see in the marketplace. So MEETS was designed to capture all of the savings from a retrofit over long periods of time, in the same way that a wind developer maintains a wind farm over long periods of time and expects to capture all of the savings from that wind farm over long periods of time. So how do we get there? How do we solve that problem? We argue that the solution to that is to meter energy efficiency efficiently and accurately over time, in the same way we do generation, and to buy it and sell it just like we do generation. That's where the MEETS transaction structure comes in. So how do we meter it? Well, this is the meter at the bullet center. That red line is a baseline derived from prior use of other buildings built to Seattle code. So Bullet was a new building, as you know, and so we did not have an existing conditions baseline for it. So we used the energy use from other buildings in Seattle built to code. That was a relatively complicated process. We're hoping to simplify going forward, but it is a baseline based on actual energy use, not on a engineered building assessment of what the energy use might be. So you take that baseline in a retrofit, it's the existing conditions in the building, it's their energy bills. And you can calibrate or normalize that baseline to what we call native load. So that's adjusted for both routine and non-routine changes to the building. Those dots along that line are the adjusted baseline. The green dots underneath are the actual energy use in the building. And the metered energy efficiency is the shaded area between the dots on the top and the dots on the bottom. So it's the difference between how the building would have performed had it not been upgraded and how the building actually performed post-upgrade. That's the metered energy efficiency. That meter was accurate at Bullet to within less than 1% the first year of operation. This is the energy efficiency statement for the Bullet Center. So what you see there are those three ovals on the statement. The one on the left is the adjusted baseline. That's the top number, or how a code building would have performed during that month. The middle oval is the energy consumption that happened in the building. And the third oval on the right is the kilowatt hour yield of energy efficiency. That's the metered energy efficiency for the building. You'll note that it's in energy units. And once we have a meter reading, we can transact. So this is how you start making it look more like a wind farm, is you actually have a meter read in the same way that you do at the side of a wind farm. So once we have that, we can transact, and that gets us to the transaction structure. So this is a super critical piece of this. MEETS is a structure. It's not an incentive. It's designed to use the savings value that's currently given away to the tenants. This is the resolution of the split incentive problem. So it uses the value that's given away to the tenants traditionally to drive deep efficiency. That value is often worth 4 to 20 times the incentive value. In the case of Bullet, in a 6-cent energy market, the net present value of the PPA is 8-fold the value of the incentives that City Light would have given to Bullet had it transacted traditionally. And that's in a very inexpensive energy market. I'll get into those numbers a bit in a little while here. Again, under MEETS, energy efficiency is metered against this dynamic baseline and sold to the utility under a long-term power purchase agreement, just like a wind farm. The utility then bills the building for the energy efficiency on the common area bill in energy units at retail rates. That's what eliminates the split incentive. The building's paying for delivered energy efficiency on its energy bill in the same way it pays for all of its other energy. And the building owner then allocates the cost from the common area bill the same way they do now. Most commercial buildings have a common area that requires energy and has a common area bill. And most building owners already allocate the energy from that common area bill to their tenants using whatever mechanism they use. This is simply another charge on that common area bill. So if the tenants are individually metered, their energy bills will go down post retrofit and their common area bill charges will go up. If there's only one bill, which would be the common area bill for the building rather, then that common area bill will be what it would be otherwise, because the common area bill for generated energy will go down and the common area bill for metered energy efficiency will go up, and they will offset each other. So the tenants will see no change. They will simply get a better building for free. I'm going to show you this graphically. So what we call an energy tenant, most people think of that as an ESCO, but we call it an energy tenant for some good reasons I'll get into. They have a long-term rental agreement to harvest and sell metered energy efficiency. So this is not a standard tenant in the building, but it acts that way. This is moving into the building, using the building in the same way that a tenant does, and paying rent the same way that any other tenant does. But this is essentially the role of the ESCO. They pay for and maintain the improvements, and they pay rent for the right to do so. So just like any other tenant, they pay rent for the right to utilize the building for their intended business purposes. The building owner has a more comfortable and valuable building, and all they do is pay a utility bill that is the equivalent of the utility bill they used to pay. The tenants have a more comfortable and highly productive building, and they simply pay their share of the utility bill, including the metered energy efficiency. The utility maintains its unit sales and its gross revenues. As I mentioned before, that's a big issue for utilities. They read the dynamic baseline meter, and they pay for the metered energy efficiency through a long-term power purchase agreement with the energy tenant. The energy tenant uses those cash flows to repay the investor who's provided the capital to fix the building. At Bullet, the traditional energy efficiency transaction structure that the Bullet Center turned down was an upfront incentive from Seattle City Light of $84,000. That obviously has a net present value of $84,000 because it's paid up front. So the net present value per square foot is $1.68. Under the MEETS agreement, that contract is worth $1.22 million with a net present value of $740,000. So that's about an 8-fold increase in the net present value to the investor. That's $14.80 a square foot. That's what gets you deep in the building. If you move the Bullet Center to a market with 15-cent energy prices, you would still get approximately the same incentive, but now the net present value of your MEETS contract would be $1.6 million, or $32 a square foot. You can get very deep in a building for $32 a square foot. This is what MEETS was designed to accomplish. For the utility, summarizing the benefits, they can target MEETS programs and turn it into a load management resource. It's location specific and reliable because it's metered. You can meter it at any interval you'd like. You only pay for units that you receive. And particularly interesting to investor-owned utilities, this should be, whether it will be or not is a regulatory issue, but it should be a rate-basable earning opportunity for them. There's no gross revenue loss and there's no unit sale loss. That unit sale loss is a really important thing to utilities who have fixed costs. As soon as you reduce the number of units in the system, which you do with traditional energy efficiency, you have fewer units to spread your fixed costs across, and that increases your cost per unit of energy in the existing system. So traditional energy efficiency, by its very nature, reduces units in the system and will drive up the cost of the remaining units. For the building owner, they have a 20 to 30-year tenant in the building paying rent. That's a new revenue stream for them. The value of the building goes up as those investments are made. The building owner does not need to use their own capital, and they don't need to get into the energy business. From an investor perspective, this is based on utility PPA. Those are very stable agreements that the investment community is very used to. They know they have performance risk, but they understand what they're going to be paid throughout the life of the PPA per unit delivered. That's a very stable mechanism, and that's what allows for much lower interest rates, which also allow for more depth. The utility is a much stronger counterparty for a long-term agreement than the building owner because the building owner tends to flip the building. You have much lower and rated payment risk with the utility as the counterparty. You have very well understood instruments, as I said, and the goal here is to scale this through aggregation. Lots of buildings, lots of PPAs become scalable for the investment community. On society's side, of course, you have a lot more jobs being created from deep retrofits, and those jobs tend to go to skilled labor because you're now dealing with HVAC and envelope issues as opposed to simple lighting retrofits, which are often done by unskilled labor. Obviously, there are significant environmental benefits associated with getting deeper in these buildings and not stranding all that energy waste in the building. You're enhancing the building stock, you're creating price stability for folks, for everybody, in fact, because you're no longer having to buy so much energy out in the markets. This does not require any tax dollars, and it doesn't require any incentives. So it's much better for non-participating ratepayers and for taxpayers. So that's what I have. We have lots of time for questions if you have any.
Hey, Rob. Scott DeWeese here from UMC. We're a Washington-based ESCO. I think one of the things that I am pondering is in our line of business, oftentimes we need to monetize for the customer something more than just energy efficiency. So the example I'm thinking of is we may have some measures that are providing an energy efficiency benefit, but there's also infrastructure renewal that the customer is valuing in a traditional transaction structure. And so I'm wondering if you have any ideas on how the energy tenant might be compensated for some of the infrastructure renewal benefits that are being delivered by, certain types of retrofit projects.
That's a great question. I went into this in some more detail in the building owner webinar. The way that the improvements in the building are accounted for in a meets transaction is by using what building owners refer to as the tenant improvement process. So to get it out of the energy space for a minute, if you move into a commercial building and you need an office put in the corner of some open space, and you need walls put in there, and you need a window, and you need a door and a doorknob, et cetera, that's all done through a process called tenant improvements, and it's a very well understood aspect of most commercial leases. In many circumstances, there's simply a tenant improvement budget that the building owner agrees to contribute, and anything beyond that, the tenant has to contribute. Other times, things are split 50-50, but it's a negotiation, essentially. In energy efficiency improvements, I agree with you that there are often non-energy benefits that come from those improvements, and at times, those improvements are more expensive than can be paid for just by the energy benefits that are being created. For instance, if you have a boiler in your building that blows up and you're the building owner, you're going to have to replace that boiler one way or the other. And it's quite possible that the capital cost of replacing that boiler, even though it will be twice as efficient as the last one, those energy benefits won't pay for the entire cost of the boiler, but you will have to replace the boiler anyway. So the negotiation would likely be that the portion of the boiler that is paid for by the energy savings will be contributed by the energy tenant, and the other portion will be covered by the building owner. Another example might be if the energy savings will pay for going from single pane windows to much better windows, whatever the state of the art is these days. The energy savings might pay for the upgrade to triple pane windows or whatever it is, but it probably won't pay for the fancy molding that the building owner wants around the windows on the first floor. There's no reason that the building owner can't pay for those themselves under the standard tenant improvement mechanism. The benefit of that mechanism is that everything in the building, whether it's paid for by the building owner or by the tenants, is owned immediately by the building owner. This is standard tenant improvement economics. It solves a lot of the balance sheet issues for the building owner where they don't want other people owning stuff in their building. This is one of the things that gets in the way of a lot of ESCO contracts. There's no equipment being leased. It's all immediately owned by the building owner. And what the energy tenant has is what is truly valuable, which is not the equipment, but the long-term contract with the utility and the right in their tenancy agreement with the building owner to harvest the energy efficiency from the building and sell it to the utility. So if you move into an office space, you don't own the door and the doorknob, but you own the right to use the door and the doorknob to get your business done. If you're the energy tenant, you won't own the new boiler, even though you paid for a chunk of it. What you do own is the right to sell that energy efficiency to the utility over a long-term contract. And your contract with the building owner goes as long as your contract with the utility. So if you look, for instance, at what's valuable at a wind farm, once the wind farm is built, it's no longer the wind turbines. It's the value of the contract with the utility. That's what's getting financed, is the value of that cash flow. Does that make sense?
Yeah, that does make sense. That definitely helps helps me understand the mechanisms that would capitalize some of the deeper energy efficiency retrofits.
Yeah. And you might even see circumstances where the non-energy benefits are less direct. I've obviously given you a really hardcore one of the boiler blowing up. Right now you have a real problem the building owner has to fix immediately. I've given you more of an aesthetic one, which is about the molding around the windows, right? But there may be all kinds of other benefits that you and I could probably make a long list of, that the building owner and the energy tenant can simply discuss in the same way that an ESCO would discuss them, to determine what the best way is to get into the building, what the building owner wants, and what the energy tenant needs in order to maximize the energy efficiency being delivered.
That's great. I have another question, so maybe I'll just launch into it now since I've already got the mic.
Sure.
I don't mean to presume that there's only going to be, one way that these transactions might be structured between the utility, the building owner, and the energy tenant. But is the idea that the utility may be able to purchase or rather recognize the revenue from the building at the retail rate, but compensate the energy tenant at something that's below the retail rate? I.e., is there enough of an arbitrage there where the utility has a net increase, or
yes.
are they?
All of that is negotiable. So there are multiple philosophies about this. The one philosophy that we've outright rejected is that you should lock the value of the PPA to retail rates so that the PPA fluctuates with retail. You can't do that because no investor will invest behind that, right? They can't have the value of their investment determined by some future change in retail rates one way or the other, right? No one would do that, right? So the key thing is that everybody knows at the beginning of the contract what the utility will pay for metered energy efficiency per unit delivered over what period of time, and that can't change without mutual agreement, obviously. So then you're going to get the gamut of what people believe is the right price to pay. So let me just toss out some ideas about that. And reasonable people are going to disagree and agree about all of these things, right? So part of my job is to help people understand what the options are and what the different philosophies might be that would support a different one argument or another. If you think about what the utility is getting, it's a really important thing to place it in that context. The utility is getting one thing that they get from all energy efficiency, which is they get a unit of energy they no longer have to buy, or that if they're long, a unit that they get to sell. So there are a lot of utilities who are in both of those places. Utilities are buying and selling power in the markets all the time. This gives them a unit of energy they didn't have. This is one of the arguments that is used for why utilities pay upfront incentives for energy efficiency. They're getting a benefit, and they should pay for that benefit. That's the argument that's been used to create the utility incentive structure that we've lived with for quite some time now. That benefit exists no matter whether you get an energy efficiency unit via MEETS or any other structure. The one thing that they get with a MEETS structure that they don't get from other structures is they get to keep the units in the system. So they don't have to spread their fixed costs across fewer units. Mm-hmm. That's a pretty important economic benefit when you think about what we're trying to accomplish. If you ask people in Seattle how much we think we need to reduce energy use in order to meet our climate goals, most people will say some number that starts at 50% and goes up from there. If you reduce the energy consumption from the building stock in Seattle by 50%, you've reduced Seattle City Lights unit sales by 50%. You will likely also have reduced their fixed costs to some degree, but by nowhere near 50%. And the result of that is that the remaining units in the system will become much more expensive. So people miss this piece. They think it's all about revenue, but it's also about unit sale loss. It's a pretty important benefit that MEETS delivers that often gets lost in the noise of trying to figure out how to contract for it or whatever. So that's an important economic piece of this. Another important piece for utilities to be thinking about is that they already have a price that they have to pay for energy efficiency. There's what I would call a must-take price for energy efficiency. Any building owner anywhere on the system at any time can do whatever transaction structure they're allowed to do, including no transaction structure at all, and simply reduce energy use on their side of the meter. They're always legally allowed to do that. They're allowed to fuel switch. They're allowed to do whatever they want. It's their building. When that happens, if that improvement qualifies for incentives, utilities are legally required to pay those incentives, and the utility loses not only the unit in the system, but they lose the gross revenue. So if you're in a 10-cent retail market and you're the utility CEO, you don't think that energy efficiency costs you 2.5 cents a kilowatt hour. You think it costs you 2.5 cents a kilowatt hour plus your 10 cents of lost retail revenue. That's 12.5 cents a kilowatt hour. Big difference from the way we generally think about this as we walk around the street. So any PPA for metered energy efficiency under MEETS that costs less than the lost retail revenue plus the incentive is better for the utility than what it's paying now. Plus, you keep the lost unit in the system. So many people will argue that the best price for a MEETS transaction is something slightly below the retail rate, the current retail rate, plus the lost incentive dollars, because the utility doesn't pay those.
Yeah, okay.
Other people will argue that because we're not trying to use incentives and MEETS was designed to not use incentives, you should leave the incentive piece alone and you should just start at approximately retail and have a lower escalation provision in the power purchase agreement, because that's another piece of the negotiation. And you should have a lower escalator in the PPA than you have in retail rates. And hence, over time, the utility will have a larger and larger net on each kilowatt hour, the further out they go. Other people argue that the utility should pay under the PPA something slightly below the retail rate, but not much. Plus, it should pay for what people call the grid benefits of energy efficiency, because that's the free kilowatt hour they get, right? When you do a retrofit of a building, you're using someone else's, not the utility's capital, to build an asset that has value to the utility by reducing load on the system, potentially ultimately reducing size of substations, right? There are grid benefits that people talk about all the time from stuff that happens behind the meter. So other people in the space argue that the building should pay for its own energy efficiency on its own bill, paying retail to the utility, and most of that should transfer to the energy tenant. And then the utility separately should pay for the grid benefits associated with that energy efficiency. So there are lots of arguments to be made for what should be paid under the PPA. But it's really important to recognize you have to compare it against what can happen without MEETs, which is energy efficiency in buildings that is really bad for the utilities business model. So MEETs offers a much better model for supporting healthy utilities. If what utilities offer is a much, much lower price than what the building owner could get doing it on their own, all of the benefits of MEETs won't happen because no one will transact that way. So if utilities think they can spend, do a MEETs PPA for 3 cents a kilowatt hour while the building owner's paying 15 cents a kilowatt hour, that's just not going to happen. Nothing will happen there. You won't get any depth. You'll be stuck with the energy efficiency structure we have now, which people are complaining a lot about. So to me, the goal is to make the utility better off than they are now and still get all the depth. And to have a set of rational conversations about what energy efficiency is worth, what it costs, and how you capture it at scale. Is that helpful?
Very helpful. Thank you, Rob.
You bet. Anything else?
I do have one more question. This one hopefully should be an easier one, or maybe a less philosophical one. I was thinking about a scenario where a tenant leaves a space in a building that has a MEETs structure in place, and a new tenant comes in, and they're perhaps a more energy intensive tenant for some reason. I'm just thinking about the mechanics of how both the energy tenant and the actual meter addresses that.
Yep.
And I'm wondering if the meter has the sophistication to sort of be able to identify that automatically, or if there's a need for the energy tenant to communicate to the meter about the change in the energy intensity of that particular tenant.
Both. If you look at the bottom of this graph, you see where it says 12.1?
Yes.
Okay. What you'll see there is that the star diverged from the green line.
Mm-hmm.
The reason that happened in this hypothetical situation is because there's more energy use happening in the building than the green line, which is the expected energy, which the meter is also tracking. So the meter expected the energy to be lower than it was. And the star is the actual utility meter. That's a flag. Something changed in the building. That's when the phone rings or email goes out, or if it's a big enough building and the energy tenant's on site, they go dig at it. If the building's big enough, my guess is the energy tenant and the building owner will be talking about tenancy changes and things like that. And if the reason that energy use in the building went up is because a tenant is using the building more, that's actual more use. And if you're using energy efficient lights more, your energy use is going up, but your energy efficiency is also going up because you're using more energy more efficiently. If you had old lights in that building, the energy use would have gone up more and more again because you'd be using inefficient lights, right?
Yeah.
So in that case, what happens is the baseline would be adjusted. So that triangle at the top, which is the baseline adjusted versus the red line, which is the predicted baseline, would go up. In this circumstance, you'll see that it didn't. And the reason it didn't was because energy use went up in the building because one of the energy efficiency systems failed. Somebody messed up the controls on the HVAC system or whatever it is. But that's a failure of the energy tenant. That's like a wind turbine failing at a wind farm, right? Mm-hmm. In which case the baseline is not adjusted because lack of use or additional use isn't necessarily energy efficiency or not energy efficiency or more use or less use, right? It could be lots of things. So when energy diverges from the baseline outside of the contractual boundary, which I think is 5% monthly and 2% annually, at least in the case of Bullet, baseline adjustments have to be addressed. So that purple line, the vertical line, is not a measurement of the green line versus the red line. It's a measurement of the stars versus the triangles, right? The actual energy use in the building versus the adjusted baseline, not the expected baseline. Does that make sense?
Yeah, it does. Yep. Well, that's all the questions I had, Rob. I really appreciate you providing such insightful and detailed responses.
Well, thank you. I love doing this, and I hope it's helpful. I'm obviously open to having more conversations about this over the phone, over email, in person, whatever people need to do. So give me a shout if you need to. Anybody else have any questions? All right, we'll wrap it up. Take care.
Thank you, Rob.
Thank you.
Thanks.
Bye.